Next, we are going to be looking at angles of depression. So these are going to be similar to angles of elevation. We're going to be using SOHCAHTOA to solve them, except now our little man is going to be standing in a different spot. So at the top here, it says name the angle of depression in the diagram. So an angle of elevation was where you have a little guy like this, and he looks straight out in front of him, and then upwards. That angle within there would be the angle of elevation. Now, angle of depression is similar, where I'm just going to put the guy up here instead, where he looks straight outwards, but then from there, he's going to look down. Then we connect that back to the man. So that angle in between here would be the angle of depression. So if we're looking at this diagram at the top, it says name the angle of depression. We need to find a spot where you look straight out and then downwards. So if I were to put my little man in this corner by the sea, then he would be looking straight outwards and downwards from there, hitting this line and then bouncing back. So this angle in between here would be the angle of depression. So we'll call that angle X. So angle X would be that angle of depression. Now they actually want us to calculate what that angle is, and that's actually pretty easy. They don't give us the number, but they give us this 72. And if you take a look, this right here would form a right angle, which means it would be 90 degrees. But if this little part of it is 72 degrees, then how much is left to make 90? Well, that would be 18 degrees. So angle X, or that angle of depression, would be 18 degrees. And now let's move on to the next example. A search and rescue helicopter spots a lost hiker at an angle of depression of 31 degrees. The helicopter is flying 1,100 feet directly above the ground rescue crew. How far to the nearest foot is the ground crew from the hiker? So right away we know that we want to find this. We want to find the ground crew and the hiker distance in between them. So it's asking us how far is the ground crew from the hiker. So we're going to be looking for this side of this triangle. And then they give us that the helicopter is flying 1,100 feet directly above the ground rescue crew. So we're going to label this side 1,100. And then it gives us that the angle of depression is 31 degrees. So remember, you need to go straight out and then downwards to find the angle of depression. So really, pretend our little man's driving the helicopter. Our angle of depression, we're going to look straight out and then downwards till we hit that line. So this here is our angle of depression of 31 degrees. So a lot of people make the mistake and they put it inside this part, but that is wrong. However, we can find that angle in there by doing that little trick we did in this try me example at the top. So we know that this whole thing is 90 degrees. And if we know that this little 31 degrees is over there, then we know that this other part needs to add up to 90. So we have to do 90 minus 31, which is equal to 59 degrees. So this little part is 59 degrees. So we labeled the important angles on that diagram. Now let's just skip right to 3. It says, what equation can you use to determine the distance from the crew to the hiker? So this is where we have to use the information that we have on the diagram. So we're going to ignore entirely this triangle on this side. We don't need this anymore. We only needed that 31 degrees so that we could find out that 59 degrees. So you know what? I'm actually going to redraw this so that's easier for us to look at. All right, so I just redrew this bottom triangle off to the side without this little top piece on it. So just imagine that bottom triangle without this top piece. So we really only needed the angle of depression so that we could find out this other angle inside the right triangle that we're actually working with. So we need to figure out the question mark, and we're going to be working from this angle because this is the one that they gave us in the question, or this is the one that we were able to solve in the question. So from there, the side with the question mark would be the opposite side from this angle, and the 1,100 would be the adjacent side to this angle, because this side over here will always be the hypotenuse since it's right across from that right angle. So because we're dealing with opposite and adjacent, we need to think of our SOHCAHTOA and which one we're going to use. So we're dealing with opposite and adjacent, or O and A. So the one that we're going to use that has O and A in it is TOA. So we're going to use tan to solve this problem. So we're going to put that the tan of 59 degrees, because we're working from this angle, is equal to, well, tan is equal to opposite over adjacent, and we know that from our TOA acronym. So the opposite side, well, we don't know what that is, so we're going to leave that blank. This would be the opposite side, but we do know what the adjacent side is. So the adjacent side is 1,100. So then we need to get that question mark all by itself, because that's what we're trying to solve for. So what we're going to do is we're going to multiply both sides of the equal sign by 1,100, because that's going to cancel it out down there and leave that question mark all on its own. But whatever we do to one side of the equal sign, we have to do to the other. So I'm definitely going to multiply the other side by 1,100 as well. So then we have 1,100 times the tan of 59 is equal to the opposite side, that question mark. So then you're just going to plug that into your calculator. We're going to ignore this step here because the booklet actually solves it a slightly different way, but I like the way we do it better. So if we do 1,100 times the tan of 59, we should get 1,830.707 is equal to the question mark, or it's equal to the opposite side. So in part 4, it says how far is the hiker from the ground crew? It would be 1,830.707 feet. So the crew needs to go, we'll just round it up, 1,831 feet to reach the hiker. And for part 5, we are just going to skip that. In the next example, it says Luke L is on a cliffside trail above a river. He sees his brother Marcel M at ground level on the far shore. The horizontal distance between them is 390 meters. Luke is looking down at an angle of depression of 72 degrees. How high is the cliff? So we're going to start off by labeling the diagram that they gave us off to the side. So let's start by labeling the height of the cliff H, or they put H meters. So the height of the cliff would be on this side, so that would be H, and they put H meters there, so you could put a little M if you want. So H meters. And then we're also going to label that angle of depression. So it says Luke is looking down at an angle of depression, so Luke is the L, and remember, we're going to look straight outwards and then downwards for that angle of depression. So the angle of depression in here would be 72 degrees. Then if we do that simple math again, we know that this is 90 degrees. So this little angle in here needs to add up with 72 to get 90. So that would be 18 degrees. And then finally, what other number could we put on here? It says the horizontal distance between them is 390 meters. So 390 can go down at the bottom because that's the horizontal distance. That's the exact horizontal line. So they want us to solve for the height of the cliff. So what we're going to do is we are going to completely ignore this top part because we only needed that angle of depression to find out this 18. Now that we have that 18, that's the angle we are going to be working with. So we need to discover what side's missing from there. So we know we're going to be working from this angle up here, this 18 degrees. So let's label our sides based on that. So if we look at this 390 meters, well, that side would be opposite from the 18 degrees because it's entirely on the opposite side of the triangle. And then we need to look for this side with the H. So that's the other side we're going to be working with. And that side would be adjacent to the 18 degrees because it's right beside the 18 degrees. It's touching this angle, but it's not the hypotenuse because remember the hypotenuse is always right across from the right angle. So again, we are dealing with adjacent and opposite, or O and A. So we are going to be using tangent for this question. So we're just going to cross out this section B here. We can ignore it. Now in part C, I'm doing it a different way than the booklet did. So I'm going to actually cross all this out and do my work right beside it. So we're going to use tangent to solve this. So I'm going to put the tangent of 18 because we're going to be working from that 18-degree angle. So that's going to be equal to opposite over adjacent. And then let's plug in the numbers we have. So the tan of 18 is equal to, we have the opposite, which is 390, but we don't have the adjacent. So that's side H. We don't have a number for that, so we'll just put an H there. So now our goal is to solve for H, but right now H is in the denominator. So we need to get that out of the denominator. So in order to do that, we need to multiply both sides by H. Because whatever you do to one side, we have to do to the other. And this way, it cancels it out in the denominator and brings it into the numerator on the other side of the equal sign. So then we have H times tan of 18 is equal to 390. And our last step is to get that H all by itself. We need to cancel out that tan of 18 next to it. So I'm going to divide by tan of 18 because multiplying and division cancel each other out. So these two things canceled out. But whatever we do to one side, we have to do to the other. So we have 390 divided by the tan of 18. So I'll just rewrite this down. We have H is all that's left on that side of the equal sign is equal to 390 divided by the tan of 18. So now we aren't solving for an angle, so you don't have to use the inverse button. We're just going to plug into our calculator 390 divided by tan of 18. And once you do that, you should get that H is equal to 1,200. So the cliff is about 1,200 meters high. So I'll stop there. I'm not going to do this next example, but I will post the answer key for it so that you can check out the solution. And if you have any questions, just let me know.